Do you feel like stealing your neighbor's bicycle and riding 15 miles to the nearest railroad track and then placing your $400 mobile phone on the tracks while the trains are coming because you feel dumber than your smartphone when it comes to math? Hot diggity. Well, we can help you avoid breaking about 5 state and federal laws by watching this here video by Fort Bend Tutoring and Mr. Witt.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about verifying trigonometric identities part 1. That's right, this is going to be a 4-part series, ladies and gentlemen, that we take a look at verifying trigonometric identities. And I really love this concept, this subject, because I look at these problems as puzzles. So I get to implement all of my gaming techniques into this, because I'm an avid video game player. And these are fun for me, okay? Trying to control myself. All right, so anyway, here in problem number 1, we're going to be verifying the trigonometric identities that you see before you. This sine x secant x equals tan x, right? So what does this mean that you need to do? Well, you need to either make the left side equal to the right side, or make the right side equal to the left side, or break down both sides of the equation until they equal to one another. That's your job. That's what you're trying to do. All right, so sounds fun, right? Okay, well, one technique that you'll be using most of the time when verifying trigonometric identities is converting every function that you see into sine and cosine functions. All right, so you'll be using those trigonometric properties that you've been introduced to in your math class. So you'll start by rewriting this as sine x, and then secant is equivalent to 1 over cosine x. All right, so using these trigonometric properties, and I'll go ahead and show you which property that I'm using as we move along. All right, and this is what I have thus far, and I can also show that sine x can be written over 1, right? Okay, and then I'll multiply that times 1 over cosine x, and so I'll end up with, multiplying straight across, sine x over cosine x. Well, it just so turns out, ladies and gentlemen, that sine x over cosine x is tan x. That's it. We're done. Once you get to a point to where I can write the left side of my equation as the right side of the initial equation, well, I'm done at that point. All right, that I verified that sine x secant x is equivalent to tan x, and I showed my steps for doing that. Yeah, so that's it. It's over. You want to make the left side equal to the right side equal to the left side, or work both sides until they equal one another. There you have it. That was problem number 1. Let's continue. All right, in problem number 2, we have cosine squared x minus sine squared x. So what I'm going to do in this problem here is use one of the Pythagorean identity properties from trigonometry to rewrite cosine squared x as 1 minus sine squared x. And then I'll bring down that negative sine squared x right here. All right, note that the way I work out most of my verification problems for trigonometric identities is that I try to make my left side equal to the right side. So that's the approach that you'll see me do in every problem. I think I always do that. Do I always do that? Yes. I always make my left side equal to the right side, unless it's just totally jacked up and I can't do it. All right, so what I can do now is I can combine my like terms over here. You see that? I have a negative sine squared x and another negative sine squared x. I'm going to combine those. So I'll be bringing down 1 minus 2 sine squared x, and I'm done. Yeah. So that's it. All I had to do was make the left side equal to the right side. So I used my Pythagorean trigonometric identity, and that was it. That was it. Left side equals to the right side. That's what you want. That's it. It's a wrap. You got it. Left side equals to the right side. Done and done. That was problem number 2. See how fun these things are? Let's move on. Problem number 3. In problem number 3, we have tangent theta plus cotangent theta equals secant theta cosecant theta. So thus far we learned that you're going to most of the time change everything in the sine and cosine, okay? That's one approach. Another approach is to make sure that you're identifying your trigonometric identities that you've been introduced to in your class, and so that's what I'll be doing in this one. In this problem, I don't see an obvious trig property at the beginning of this problem, but I do know that I can change everything into sine and cosine, so that's exactly what I'm going to do. So I know that tan theta is equivalent to sine theta divided by cosine theta, and I know that cotangent theta is equivalent to cosine theta divided by sine theta. All right. So far, all I've done is rewritten everything in terms of sine theta and cosine theta, which is a good step. And now I am literally looking at what they're asking me to do here. They're asking me to add this fraction to that fraction. Well, one thing I know about adding fractions is that I need a common denominator. So that's exactly what I'm going to do here. I know that the common denominator for these two fractions is going to be cosine theta times sine theta. So I'm going to write my denominators as cosine theta, sine theta for both of my fractions here. All right. So that's what I have thus far. Then, knowing that I changed the denominator, I need to get an equivalent fraction. So since I multiplied the first denominator times sine theta, I need to multiply the numerator by that as well. So sine theta times sine theta gives me sine squared theta. All right? Sine squared theta. That's what's up. Then, on the second fraction, I multiply the original denominator by cosine theta. So multiplying that same cosine theta times the original cosine theta in the numerator gives me cosine squared theta. Just like that. You like that? Now, combining your numerators together, adding together the sine squared theta plus the cosine squared theta, it'll look like this. All right, I'm going to show my work because that's what I do. Showing my work so you see what's going on. That's an ugly 2, and I'm going to fix it. Okay, because it's just ridiculously ugly, and we're not going to have that today. Oh my God, how did I repeat that? Okay, there we go. That's a better 2, which now makes this 2 look ugly. All right, so I'm gonna fix this. See, because I gotta give you the good stuff here. I gotta give you the good stuff. All right, so here we have it. There you go. Now it looks better. All of this, ladies and gentlemen, is going to be over your common denominator of cosine theta. Yeah, sine theta. Just like that. Okay? All right? So that's what we have thus far. Now, once again, utilizing those Pythagorean identities from trigonometry, I know that sine squared theta plus cosine squared theta equals to 1. So this is rewritten now as 1 over the denominator, which is cosine theta sine theta. And if I were to expand this fraction, this ratio, into 1 over cosine theta times 1 over sine theta, all right, and now we should know, all right, you and I, we should know that 1 over cosine theta is equivalent to secant theta, all right, because secant theta is the reciprocal of cosine theta. And when it comes to 1 over sine theta, that's equivalent to cosecant theta. So let's go ahead and write that down. 1 over sine theta is equivalent to cosecant theta. There you have it. Well, that's exactly what they asked me to write the left side into. So if you look back at your original problem number 3, we were able to rewrite tan theta plus cotangent theta into the right side, which is secant theta, cosecant theta, which is awesome and done. That's right. It's over. I just verified it. Yeah, I just showed you step by step how I was able to make the left side equal to the right side. I'm having too much fun. Way too much fun. All right, I'm ready to move on. Problem number 4. We have sine squared theta times 1 plus cotangent squared theta equals 1. Once again, I'll be working the left side and making it equal to the right side. Not that I have to. It's because I choose to, all right? Generally, these problems are already designed for you to work the left side to make it equal to the right side. There are exceptions, of course. But the problems I'll be showing you in this series, it's going to be the left side being made into the right side, all right? But just know that you have that flexibility. You have a choice. You do, okay? But I'm doing it this way. So here, what I do notice is that, once again, I have a Pythagorean identity here. And that is that 1 plus cotangent squared theta is equivalent to cosecant squared theta. And I'll write that down right now. I'll have sine squared theta. Oh my God, what is wrong with me in these 2's? I'm going to fix it. I'm going to fix it. One of these days I'll learn how to write things legibly. And then, once again, we said that this was going to be, here it is, cosecant squared theta. All right, there you have it. Now, breaking things down into only sine and cosine terms, I can show that I have sine squared theta, which can be written over 1, times this cosecant squared theta, which can be written as 1 over sine squared theta. Check that out. Right. Now, ladies and gentlemen, I prefer to simplify before I multiply, okay? So I'm going to show that this sine squared theta goes into itself once. Oh, yes. And that sine squared theta goes into itself once again. Then, multiplying straight across, 1 times 1 is 1, and 1 times 1 is 1, and you know that 1 over 1 is 1. There it is. Okay, so that's the answer. That's what I want. I wanted to show that I could rewrite the left side into the right side, and I did just that. I did just that. Exactly that. Using only the left side, we equal to 1, which is what we had on the right side. I'm verifying that this left side equals the right side. That's what they're asking of me. Showing my work. It's done. It's done. It's over. It's over now. Okay? There you have it. That was problem number 4. That was problem number 4. Let's move on. Here we have problem number 5. With problem number 5, we have sine x over cosine x plus 1. Plus cosine x minus 1 over sine x, and that's supposed to equal to 0. All right, so we're going to take all of this mess over here on the left side and make it equal the right side. That's what we're going to do. Okay, I'm going to start out realizing that everything's already written in sine and cosine terms. And I also know that they're asking me to add these two fractions, these rational expressions together. All right, well, I know that I need a common denominator. So the common denominator is going to be the product. That's why we're multiplying. Cosine x plus 1 times sine x. So that's going to be my LCD, my least common denominator. All right, so setting up my framework, I'll write my denominators as sine x times cosine x, that's an S right there, plus 1, all right, that's in that denominator. And then I also have another denominator that has sine x times cosine x, plus 1. There you go. Now, knowing that I've rewritten these denominators with my least common denominator, I need to get an equivalent fraction. In other words, I need to multiply the numerator by what I had to multiply the denominator by. My original denominator in this first fraction was cosine x plus 1. I multiplied by sine x, which means I need to multiply the numerator by sine x. And sine x times sine x, you know it. Yeah, it's sine squared x. Oh, these 2's. Oh, what am I going to do with these 2's? What am I going to do with these 2's? What am I going to do with these 2's? All right, then we multiply the second term's denominator by cosine x plus 1. So multiply the numerator by cosine x plus 1. Let's do that together. So we'll have the cosine x minus 1 being multiplied by that cosine x plus 1. All right, so that's the way it looks thus far, okay? This is still my left side that I'm rewriting, all right, through steps, of course, to equal to 0. All right, that's what I'm trying to show. That's what I'm trying to prove. That's what I'm trying to verify. All right, so next we'll do the following. Now that I have a common denominator, I can add the numerators together. All right, so let's be creative here. Let's go ahead and bring down that sine squared x. Let's bring that down. And if you were to FOIL the right side here, all right, I'll go ahead and show my steps. I'll show my steps. That cosine x times cosine x is going to be a positive cosine squared x. Yeah. And that cosine x times 1 is cosine x. All right. Then negative 1 times cosine x is a negative cosine x. And then negative 1 times 1 is negative 1. It sure is. All of this is going to be over that common denominator. You got it. Sine x times cosine x plus 1. All right, let's get this together. All right, there we have it. There we have it. That's what's up. Okay, now what happens at this point? Let's see. Well, the cosine x's, they'll cancel out, right? They're additive inverses. They're opposites. So those are gone. They're gone now. Now I'm noticing that sine squared x plus cosine squared x in the numerator. That's a Pythagorean identity. Sine squared x plus cosine squared x equals to 1, ladies and gentlemen. All right, so that means I'll be rewriting these terms right here. I'm gonna go ahead and circle that. That equals 1. Yeah, then I have that minus 1 right there. That's gonna be over my common denominator, which is sine x times cosine x plus 1. All right, let's go ahead and extend that. There you go, extendo. All right, there you go. So now we have 1 minus 1, that's 0. 0 over the common denominator, sine x times cosine x. Let's write that out. Let's write that out. Plus 1. There you have it. 0 over any number other than 0, ladies and gentlemen, is 0. We're done. That's right. You wanted to make the left side into the right side? You just did it. You just did it. You and I. We were together. We went through that long journey, hand in hand, and we got to the end. That was number 5. Let's move on. Moving on. As I told you before, these things are fun. They are fun. All right, so yeah, we have tan theta cotangent theta over cosecant theta and it equals to sine theta. What we're going to do with this problem is we're going to rewrite every single function on the left side of the equal sign into terms of sine and cosine. That's what we'll do first. All right, so I'm going to rewrite my tan theta as sine theta, there you go, over cosine theta. This is going to be times cotangent theta, which is cosine theta over sine theta. There we go, there we go, there we go. Okay. All of this is going to be over, all right, that cosecant theta over there, that's equivalent to 1 over sine theta. All right. So what do I do with this? Well, in the numerator, this sine theta and that sine theta cancels out to 1. And the cosine theta and the other cosine theta, they also cancel out to 1. Yes, life is good. So multiplying everything across, you get 1 over 1, which is just 1. So now I have 1 over sine theta. Well, what you have before you is what we call a complex fraction, a fraction within a fraction. I can rewrite this as 1 divided by 1 over sine theta. Okay, there you go, there you go, there you go. All right, then knowing that when I'm dividing fractions, I need to change the operation and multiply by the reciprocal of the second fraction. Thank you. I'll end up with 1 times sine theta over 1. Multiplying this straight across, you'll end up with sine theta over 1, which is sine theta. We're done. Yeah, that's it. We just verified this problem. Left side now equals the right side. Done. That was problem number 6. Hope you enjoyed that. Let's move on to our next problem. We have problem number 7 in play. Okay, that's problem number 7. It's tan squared x minus sine squared x equals tan squared x sine squared x. We're going to use that tried and true strategy of changing everything into sine and cosine functions. All right, so tan squared x is equivalent to sine squared x over cosine squared x minus sine squared x, and let's place this sine squared x over 1. Okay, let's do that. There you go. Now once again I'm looking at 2 fractions, but this time they're asking me to subtract them. I still need a common denominator. So I'll be rewriting this as sine squared x over cosine squared x. All right, and then I'll be rewriting this with a common denominator of cosine squared x, and of course in the numerator, since I had to multiply the denominator by cosine squared x, I need to multiply the numerator by cosine squared x. So I have sine squared x times cosine squared x in the numerator. Just like that. All right, so that's what we're looking at thus far. All right, check it out, check it out. Now I'll be combining these numerators together. All right, so I'll show that step. All right, give the teachers something to see. All right, they want to see all my steps, they want to see all my work. So here I have this showing them that I knew I could combine the numerators together. Yes, that was an S. Okay, and then I'll be factoring out sine squared x in the numerator. That's exactly what I'll be doing. Factoring out sine squared x in the numerator. So I'll have sine squared x times 1 minus cosine squared x. All right, all of this is going to be over that cosine squared x, like so. All right, so now let me show you what happens. I'm going to grab this right here, that sine squared x over cosine squared x. I'm going to grab that, and that's going to be equivalent to tan. Yeah, it will. So I know that I can rewrite this as tan squared x times this 1 minus cosine squared x. Now manipulating the Pythagorean identity sine squared x plus cosine squared x equals 1 and solving for sine squared x, you'll end up with this 1 minus cosine squared x. So it's going to be substituted with sine squared x. So I bring over that tan squared x, all right? And remember, I'm substituting the 1 minus cosine squared x with sine squared x. Just like so. All right, and we have just verified problem number 7. Check mark right there. That's supposed to be a check mark. It's ugly. Let me fix it. There you go. All right, that's a better check mark. So we just verified problem number 7. Done. Once you make your left side equal to the right side, you're done. It's over. All right, got one more problem for you for this part 1 of verifying trigonometric identities. Okay, let's check it out. You're going to love this. You're going to love this. Problem number 8. We have the log of secant x minus tan x plus the log of secant x plus tan x equals 0. Good stuff, right? Well, using my logarithmic properties, I know that anytime I have the sum of the exact same logarithm, all right, that sum can be rewritten as multiplication. Yeah, it's one of the logarithmic properties. It's beautiful, all right? So that means that I can rewrite this as log of secant x minus tan x times secant x plus tan x, all right? There you have it. There you have it. Okay. Here we go. Once I have this, ladies and gentlemen, let's go ahead and multiply everything out in here. Okay, let's go ahead and FOIL it out. All right, I prefer the distributive property, but I know a lot of you learned it as the FOIL method, but it's the same thing. It's the same thing. Secant x times secant x is going to give, you know what, first of all, my favorite property in the world is distributive property. I cannot move on without showing you that I'm about to get my arrows popping, ladies and gentlemen, okay? There you go. Let's get our arrows popping. Okay, thank you. Just indulge me. So secant x times secant x is going to give me secant squared x. Secant x times tan x is going to be a positive secant x tan x, like so. All right. Then a negative tan x times secant x is going to be a negative secant x tan x. There you go. All right. Okay, enjoy that. Then you have a negative tan x times tan x is going to give you a negative, we'll just throw it down here, a negative tan squared x. All right, that's what we have thus far. Now what happens, ladies and gentlemen, is that my middle terms will cancel out. Yes, they're gone now. Okay, isn't that beautiful? And what I'll be doing next is the following. I'll be rewriting this secant squared x as, all right, check me out. I'm going to show that secant squared x is equivalent to 1 plus tan squared x. All right, and I still have that negative tan squared x from the previous step. Okay, now what happens is my tan squared x's will cancel out. Goodbye. Yeah, they're additive inverses. So that means that I now have the log of 1. When you just see log, it just means that you have a logarithm in base 10. So I'm going to show that I have my log, which is in base 10, by the way, and I'm going to rewrite 1 in the form of 10 to the 0 power. Well, one of our logarithmic properties is that anytime the base of your logarithm and the base of your value is the exact same, that those will actually just cancel out. Oh yes, to give you this value here. Your exponent becomes your result. And so since my exponent was 0, my answer is now 0, and I have just verified problem number 8. Thank you. I feel good about that. That was fun. And this is only part 1, ladies and gentlemen, of verifying trigonometric identities from me, Mr. Witt, and Fort Bend Tutoring. Hopefully you enjoyed those first 8. I didn't want to make a 2 or 3 hour video that showcased all 4 parts, ladies and gentlemen, so that's why I broke them up into 4 parts. So indulge me by going ahead and looking at part 2, part 3, and part 4 individually. Nice little bite-sized chunks customized just for you. All right, and as always, please rate, comment, and subscribe, and ladies and gentlemen, if you're able, please donate, as that helps me and Fort Bend Tutoring provide you with free math tutorials. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook, we'd be much obliged.